Hi there and welcome to lesson 9.3 on solving quadratic equations. In today's lesson, I'm going to teach you how to solve a quadratic equation by finding its square roots. And when you find the square roots, then you can graph the quadratic function with the square roots and the vertex. And we're going to see that today. So first of all, the solutions to a quadratic function are just the x-intercepts. It's the place where the parabola is going to touch the x-axis on the coordinate plane, okay, x-intercepts. Now, these x-intercepts, these solutions are often called roots of the equation, and you're going to see why they're called roots here in just a minute when we start solving. So when you think about graphing a parabola on a coordinate plane, there's a few different ways that can look. Right? Now, if you look at the first picture on the left, you're going to see that that parabola touches the x-axis twice in two locations. And so we would say that this quadratic equation has two solutions because it has two x-intercepts, two places where it's going to cross the x-axis. Now, the one in the middle, do you see how the vertex is touching the x-axis? When the vertex is the only point touching the x-axis, there's only one x-intercept, so there's only one solution. And if you have a parabola that's floating above the x-axis or maybe below the x-axis, it's not going to touch it at all. So we would say that has zero solutions or no solutions. So these are the three different ways that a parabola could look on a coordinate plane. So when you're finding solutions, you're either going to have two solutions, one solution, or no solutions, depending on how many times it touches the x-axis, because a solution is the x-intercepts. Okay, so let's try and connect this to something that you already know. We know how to graph a quadratic function. So I have y equals 2x squared minus 8. Now, what I want to do here is just go ahead and plug in some input values. And I made you a table right here. And we're just going to plug in the values -2, -1, 0, 1, and 2 right into that function. And then we're just going to do a quick sketch of the parabola. So easiest number to plug in is 0. And when you plug 0 in for x, we're just plugging 0 right in here for x to get the value of y. You get -8. And then if we plug in +1, we would get -6. And we know that would be the same answer as if we plugged in -1, we get -6. And if you plug in +2 into the function, you would get 0, which is the same thing you would get if you plugged in -2. Okay, so let's just go over to the table, or the graph, and we're just going to plot those points: -2, 0, -1, -6, the vertex, which is 0, -8, 1, -6, and 2, 0. So I just got 5 points here on the parabola. And if you notice that there's no b value in the equation, that's why we have our vertex right on the y-axis. So then connect the points in your notes to make the parabola. Okay, so let's talk about the solutions. Remember, those are x-intercepts. So when you look at the parabola that we just graphed, where is it touching the x-axis? I'm going to change those points to red. Do you see? Those are the two places it's touching the x-axis. And so this has two solutions. And we could say that that's at the point -2, 0 and +2, 0. Those are the two x-intercepts. So those are the two solutions. Okay, so let's now see, could I find the solutions a different way? Or because I don't have to graph, and graphing isn't always going to be the most practical way. So I can use algebra in order to solve for these two solutions that I can see on the coordinate plane here. So if you go back up to the equation, it is, y equals 2x squared minus 8, okay? Now, any point that's on the x-axis has the value 0 for y. So if you look at the 2 points that we just found as the two solutions here, see how they're on the x-axis? They both have 0 in the spot for y. So when you're trying to solve for an x-intercept, we want to say, okay, let's change y into a 0 because all points on the x-axis have a y for 0. And then I'm just going to copy the rest of the equation. Okay, so I want to figure out when y is 0, what's the value of x? So I'm just going to solve this algebraically. I'm going to solve for x. So we'll add the 8. 0 plus 8 is 8. 2x squared, so we wouldn't want to divide by 2. Okay, I'm going to move it over here. So we would get 4 equals x squared, and I want to just figure out the value of x. So I'd have to take the square root, because that is the opposite of squaring a number, and I have to take the square root on the other side. Now, square root of 4. Now that would be positive 2, because 2 times 2 is 4, but also it could be negative 2, because negative 2 times negative 2 is also 4. So I could get two solutions here. Now I could say x equals 2, x equals negative 2. I could put them written both as an ordered pair. I could also say that x equals positive and negative 2 with this notation, which you saw earlier this year. So any of those ways are perfectly fine to write your solutions for your quadratic equation. Now, solving algebraically is really a great, easy way to solve for your solutions, but it only works sometimes. So let's take a look at this equation, y equals 2x squared minus 8. It's missing a b value. And so when you're solving a quadratic function, the only time that you can use algebra, like we just did, is when the b value is 0. That's the only time that that's going to work. So on the examples we're going to see today in our notes, you're going to notice that the b value is always going to be 0. Okay. So let's give this a try. Here I'm going to give you a quadratic function, y equals x squared minus 9, and we are going to find the roots, find the vertex, and make a quick sketch of the graph. Okay, so if I want to find the roots, I know that those are the x-intercepts, so I want to set y equal to 0, because I know any point on the x-axis, y is going to be 0. And then I'm going to solve this algebraically. So to get x, I'd have to minus the 9. Oh, I'm sorry, I copied that wrong. I was like, this isn't going to work. Okay, that's a minus 9. Okay, I'd have to add the 9, and I get 9 equals x squared. So square root of x, square root over here, square root of 9. Now that's going to be 3, but it's also going to be negative 3. So I have two solutions here. I could also write this as x equals positive and negative 3. I could also write these as ordered pairs. So now I have the two solutions. So I can go ahead and graph them. You'll see I graphed them both there in red. Okay, now let's find the vertex. In order to find the vertex, I'm going to use x equals negative b over 2a. So in my function, x equals negative b, there's no b, it's 0 over 2 times a. Anytime you take 0 and you divide it by anything, you're going to get 0. Okay, so I know that the x coordinate is 0, so I'm going to plug that in right here, 0, and I would get negative 9. So there's the vertex. So I just want you to go ahead and graph negative 9. You see I did that there in blue. And then we can connect and make a parabola. So that's just a quick sketch. And you see with those 3 points, I was able to get the shape of the parabola. I just needed the two intercepts, the two solutions, and then the vertex. Okay, let's go ahead and try another one. Okay, so here on number 2, we're going to do the same thing. We're going to find the roots first. So that's our solutions, with which we know they're x-intercepts. We're going to set y equal to 0. Okay, there we go. And I copied that wrong again. Okay, so I'm getting ready to solve. I have to take away 5. Take away 5. I get x squared equals negative 5. And then when I take the square root of x, I have to take the square root over here. Wait a minute. Can you take the square root of a negative number? If you try typing this into your calculator, it will tell you that there's an error. You can't take the square root of a negative number. You get something that's imaginary. So this doesn't work. There's no solution for this. Okay, we learned this in chapter 10. No solution. Man, well, how am I going to get a graph on here? Well, let's find the vertex. Okay, so vertex, we'd have x equals negative b, which is negative 0 over 2 times a. And again, this is just going to give us 0. So the x coordinate 0. Let's plug in 0 right here for x. Well, then y would be 5. So let's go ahead and graph the point 0, 5. Now, remember, there's no roots. There's no solutions. This isn't going to touch the x-axis at all. So think, what would the parabola have to look like? Like that, it opens upward, right? Because it's got a positive a value. So just a quick sketch there, you can see, oh, that's why there's no solution. That's why we got no solution when we were trying to find the roots, because it's not going to touch the x-axis anywhere. Okay, let's try a third one. All right, so we're going to solve first algebraically to find our roots. So make the y a 0. Okay, so I'd have to, here I'd have to divide by 1/2 or multiply by the reciprocal. Doesn't really matter. Either way, if I take 0 divided by 1/2 or 0 times the reciprocal of 2, I'm going to get 0. So now take square root of 0. Well, there's only one solution. The square root of 0, the only answer is 0. There's not a positive and a negative 0. So I get one solution here, x equals 0. That's the only place where this parabola is going to touch the x-axis. So I'm just going to graph that right here. That's going to be my solution. It's touching the x-axis there. And if I were to find the vertex, that would be x equals negative b over 2a. That would be negative 0 over 2 times 1/2, which still would give you a value of 0. So x is 0. And if I plug in 0 for x, y would also be 0. So the vertex is also right here. And if I graph the parabola, just make a quick sketch here, it's got one solution, yes, and that one solution is the vertex, and that's the only place where it's going to touch. So here you have examples of 2 solutions in number 1, no solutions, 0 solutions in number 2, and in number 3 you have 1 solution. Again, remember the solutions are the places where the parabola touches the x-axis. They're the x-intercepts. Okay, in these next couple examples, we are just going to solve the equation algebraically, no graphing or anything. So I'm going to give you the equation. Whoops. Back that up. Okay, so this is the equation, y equals x squared minus 36. Notice there's no b value because you cannot algebraically solve a quadratic function that has a b value. So here's our equation. And now if we want to solve it for the solutions, we want to make y into a 0. So you saw that y just appeared as a 0 because any number on the x-axis has a y for 0. So now let's go ahead and solve. We're going to get 36, square root of x, square root of 36. Now when you have the square root of 36, you get 2 answers. You're going to get a positive 6, but you're also going to get a negative 6. 2 answers, positive and negative 6. So you could write them also as ordered pairs, negative 6, 0, or positive 6, 0, right? There's a few different ways you could write this, but this one's going to have 2 solutions. Okay, let's try number 5. Here's your quadratic equation. If we're going to solve it algebraically for the solutions, we need y to be a 0. So I'm going to change it to a 0. Adding 15. Dividing by negative 3. Taking square root. Cannot take the square root of a negative number, so no solution. You won't have any solutions. So that means that, remember, the parabola, in this case, being that the a value is negative, it's going to be kind of somewhere down here. It's going to be opening downward, but it's not going to touch the x-axis at all. Okay, let's see what happens with number 6. So here's your function, y equals 4x squared. Let's make the y into a 0. Divide by 4. 0 equals x squared. Squared. The only square root of 0 is 0. So this one's going to have 1 solution. And so that would mean it's only going to touch the x-axis right here at the vertex. So it's going to look something like this. Okay, so we got 1 solution. So, and in this case, this solution would end up being 0, 0. Because think, if you took this x equals 0, plugged it back up into here, the y would also be 0. So we got 0, 0 there. So here we have an example again of two solutions, no solutions, and one solution. Okay, let's go to our summary. When you're solving a quadratic equation, it could have 0 solutions, 1 solution, or it could have 2 solutions. The solutions are the x-intercepts. It's the place where the parabola is going to touch the x-axis. And how do we find that? Well, we have to take the quadratic equation, set the y equal to 0, and then we solve the equation. And this only works when there's no b value. Thanks for joining me today. Have a great time solving quadratic equations algebraically.